Welcome. Kahano is a platform working to compile a database of pre-approved civil engineering designs to help accelerate project timelines and therefore save on costs. This cost saving is for both the average person building their home or larger property development companies to enjoy. In this training video, we look at the design of a home septic tank. If you are designing a house in an area without municipal sewer infrastructure, then understanding septic tank design is absolutely essential. A poorly designed septic tank can cause groundwater contamination, bad odors, structural failure, and expensive repairs would then be in order. But a properly designed brick wall septic tank can last for decades. In this video, I'm going to show you step by step how a septic tank works, how to size them, how to design the brick walls, how to calculate capacity, the inlet and outlet requirements, ventilation requirements, soakaway systems, and the most common design mistakes to avoid. Let's get started. What is a septic tank? A septic tank is an underground wastewater treatment structure commonly used in areas without centralized sewer systems. Its purpose is to collect wastewater, separate solids from liquids, and allow partial treatment before discharge into a soakaway or drainage field. A tank usually receives toilet waste, bathroom wastewater, and kitchen wastewater. The tank is not to receive chemicals such as paint or oils. Inside the tank, heavy solids settle to the bottom as sludge. Oils and grease floats to the top as scum. Liquid effluent flows out into the soakaway. The septic tank must therefore be watertight, be structurally stable, and provide enough retention time for settlement. We refer to SANS 10252-2 and SANS 10400 Part Q as the primary design standards used in the following example. Site investigation. Before designing the septic tank, you must investigate the site conditions. Key factors include 1. Soil type, as clay soils drain poorly and sandy soils drain faster. 2. Groundwater level. Never place a septic tank in areas with high water table. 3. Percolation test. This determines whether the soil can absorb effluent efficiently. 4. Separation distances. A septic tank should be located away from boreholes, rivers, buildings, and property boundaries. Typical minimum clearances include a 5-meter clearance from buildings and 30 meters from any water source. Always check local municipal regulations. Septic tank sizing. Now let's size the septic tank. The size depends mainly on the number of users, daily wastewater flow, and retention period. In this example, we are going to design for a 4-bedroom house, a dwelling for 8 persons. We assume that 150 liters of water is allowed per person per day. Therefore, 8 times 150 is 1,200 liters of water to be designed for per day. A septic tank will therefore require 24 to 48 hours retention time. In this example, we will use 24 hours. The required volume of the septic tank will therefore be 1,200 liters, also converted to 1.2 cubic meters minimum. In practical situations, septic tanks can be larger. A common residential septic tank may have a length of 2.5 meters width of 1.2 meters and a liquid depth of 1.5 meters. Note that the actual depth of the tank will include a 1 meter scum, as well as 0.5 meters for freeboard. Therefore, our design volume is 2.5 by 1.2 by 1.5, totaling 4.5 cubic meters. And this provides adequate settlement capacity. Brick wall design. Now let's discuss the brick wall structure itself. Because the tank is underground, the walls must resist earth pressure, water pressure, and surcharge loads. Typical wall construction will be a double brick wall, cement and mortar brick wall, and it will have waterproof plaster internally. Common specifications will include a 220 millimeter brick wall thickness, class 2 engineering bricks, and a 1:4 cement mortar mix. The internal plaster will be 20 millimeters with an admixture for waterproof properties. The walls must be fully watertight to prevent leakage. Floor slab and roof slab. The base slab is typically reinforced concrete. Why? Because it prevents settlement, prevents groundwater intrusion, and supports wall loads. A typical slab will therefore have a thickness of 150 millimeters with Y10 reinforcement bars and a 25 MPa concrete strength. The roof slab should also be reinforced. We will also include access manholes and ventilation pipe openings. The manholes are essential for inspection, pumping sludge, and general maintenance. Inlet, outlet, and baffles. The inlet pipe carries wastewater into the tank. The outlet pipe discharges treated effluent to the soakaway. It's important to note the outlet invert level must be lower than the inlet. Baffles help to reduce turbulence, improve settlement, and prevent scum escape. PVC pipes are commonly used with a diameter of 110 millimeters. Proper pipe slopes are critical. Soakaway design. The soakaway disposes treated effluent into the soil. Design depends on soil permeability, effluent volume, groundwater level, ground slope, and the water table depth. Typical soakaway types include rubble-filled pits or perforated pipe trenches. Never undersize the soakaway. A failing soakaway can cause overflow, bad odors, and surface ponding. Common design mistakes. Common septic tank design mistakes include undersized tanks, poor waterproofing, incorrect pipe slopes, inadequate ventilation, building too close to structures, and ignoring groundwater levels. These mistakes lead to expensive failures. In conclusion, designing a brick wall septic tank requires hydraulic understanding, structural design, site investigation, and good construction practices, such as checking levels, checking slopes, benching, and the use of waterproofing. When designed properly, septic systems are reliable, durable, and cost-effective.